All right, before we get started, I'm just going to scroll through example 3 really quick. Like with the other examples, if you don't have access to this OneNote document, that's okay. Just go ahead and pause any of this point while I'm scrolling through to be able to read what we're going to be talking about throughout this example. Keep in mind also that in class, we're going to be covering this in more detail. So if you have questions, go ahead and bring those to class. And then also keep in mind that the homework 3 is going to correspond to example 3, and we do have some videos that go along with those. We're going to talk about analog sensors. So there's a video on those. There's a video on else-if statements, else statements, and then the ifs, the else-if, and the else all together, and reading code with some if statements, just some practice with that. All right. So real quick, before we go start working through the example, just a quick overview. So far, we've been using digital pins, and digital pins we've been saying are either they're binary. They are either on or they're off, they're true or they're false, they're 0 or they're 1. And now we're going to talk about analog, and what analog is it's the opposite of that. Now you might say, what's the opposite of on and off? Really what digital is it means that we have steps between different things. And so if you look at a digital clock, the numbers go from 12 o'clock to 12:01 to 12:02, and there's these hops that happen between each step. If you have an analog clock, one with the hands, it sweeps through the entire thing, and at every single point, that arm has to be somewhere. And so you can actually see the in-between spaces. Analog just means continuous, where digital means that we're hopping between things. Now, since the sensors that we're using are going to be used with the Arduino, which is a digital thing, just like a computer is a digital thing, we're going to have to fake the analog signal. And so we'll talk about kind of how that happens, but I just kind of want to give an overview about what analog is so that we have an idea of what we're going to be getting into. There are a couple different ways to hook up analog sensors depending on what type of sensor you're dealing with. In class, we're primarily going to be starting off with 2, either a potentiometer, that's like a dial, and it's set up as follows, or we have our photoresistor, which is set up like this. And for now, if you have a question, just copy how it's set up, and we can talk more about how it works and why it's set up that way in class or another time. When we have our button, which is on our digital side, which is connected up on the top part of our board, we get 0s or 1s. When we connect down here on our analog side, I'm going to get different values. I'm going to get an array of values, or I guess I should say a large possibility of values. On the low end, we can get a value of 0. On the high end, we get a value of 1023. And those seem kind of random. We'll talk again in class about why those numbers are what they are. I have videos about why those are what they are. We have that analog video. But really quickly, the Arduino deals with 5 volts. And so if it's reading 0 volts through the sensor, then it gives us a 0 for a value. If we're reading 5 volts through the sensor, then we're getting our maximum value of 1023. And the thing about our analog sensors is instead of them being on or off, and those are the only options, they can be partway on or partway off. Such as with a dial, if I turn this dial halfway up, then I'm somewhere in between on and off. And if I'm right in the middle, then I'm going to be halfway between 0 and 5 volts, which means I'm going to get a value, an analog value between 0 and 1023. I'm going to get a value of about 511, 512. All right, so let's go ahead and take a look at a circuit, and then we'll talk about the analog sensor maybe a little bit more as it runs, and we'll talk about the if, the else if, and the else statements. I went ahead and I already made a circuit. Let me make sure this is the right circuit. If we go down here to the example problem, we're going to set up an analog sensor with at least 3 LEDs. So I just did a potentiometer and 3 LEDs. We're going to use an analog read to find and store the values of the analog sensor. We're going to use that stored value to use one if statement, one else if, and one else statement. We'll talk about what those are briefly in a second. I do have videos about those as well. And so let's go ahead and take a look at what we have so far. So I already set this circuit up. Let me zoom out just a tiny bit. I already set this circuit up, and we can take a look at this circuit for a second. I have 5 volts connected down here. I'm going to use that to power my potentiometer. That's on the right side of my potentiometer. The very left side of my potentiometer is going to be grounded, which we have. And that middle leg, that middle pin, is going to be our signal pin. I have that connected to analog pin 3 for now. We've set up a lot of LEDs, so we can take a look at those as well. Or you can take a look at them as well. I'm not going to go into those specifically. Now, I like to, just to make sure everything's working well, when I first set up a circuit, I like to make a just a simple code. It's a test code. Maybe you could call it a calibration code, whatever you want to call it. And I have that set up right here. And if you look at it, all it does is it sets up my digital pins. It gets ready to print something so I can see what's happening. In this case, I'm going to print the values of the potentiometer. Then I take a reading of the potentiometer, I can print it to the screen, and I turn on the LEDs. Now I do that just to make sure that my circuit is working with code before I get too far, because the last thing I want to do is write a whole bunch of code, and then when things don't work, I'm not sure whether it is, did I screw up on the circuit somewhere, or is it somewhere in the code? So if I run this right now, I'm going to be able to see, number one, hopefully this simple code works, which it is running. All 3 of my LEDs turn on. That's a good sign. That means those 3 LEDs are connected appropriately. I'm going to open up my serial monitor really quick. And I'm just going to play around with my potentiometer for a second, make sure that it's getting readings. Now, if I go all the way to the maximum, I mentioned that we're going to get a maximum value of 1023. If I go all the way to the minimum, I get a value of 0. And if I'm halfway up, I'm going to get that 511, 512, somewhere in there. So it looks like it's working. That's great. I'm going to go ahead and stop the simulation for now, because what I want to do is I want to get rid of the code that I have in here right now, or modify the code at least. I don't need that code. That was just to test everything. Now, if this was you doing homework or a project, I would save this and I would call it something. This is what, homework or example 3. And so what I would do is I would save this code and say something like, this is example 3 test code, or circuit test for example 3, or something like that. Anytime I want to build a circuit and I want to test out that it works, I can just upload this really quick and it all works really well. If I wanted to, I could make variables for these. I just did this really quick just to make sure that it was running. But even in a test code, we could use variables that way. If you want to change up where things are located when you actually run the circuit, you can do that, and you can change that in this test code. All right, but what I want to do is I want to go ahead and I want to get started. First things first, we're always going to set up our variables. I have 3 digital pins. I'm going to set up 3 digital variables for them. I'm just going to call it LED1, which is going to be, let's call our blue one LED1. So that's going to be in digital pin 4. LED2 is going to be digital pin 7, and so forth. Now, why am I calling these LED 1, 2, and 3 instead of green, yellow, and blue? Because I can. In our previous examples, I called them R for red or G for green. Also, why are they spaced out? No reason. I'm just showing you that you can do that. These are options. I'm going to go into these pin modes and I'm going to update them so that they're using my variables. So at this point, nothing should have changed. I'm going to make these quick changes. I'm going to come down here and I'm going to make the changes. And then I'm going to run it one more time just to make sure that those changes worked, and not the fact that it wouldn't work, the process doesn't work, making sure the fact that I didn't mess something up. All right, so they all come on again. That's great. So everything's working good so far. I'm going to go ahead and I'm going to keep my serial.begin in here because I do want to know what's happening with my potentiometer while I run this. Let's see, I am using a 3 here inside of my analog read. That's going to be my analog pin. It's going to be my location. Analog read is like digital read. It reads a pin. Our digital read would read a pin when I press the button. It would return either a 0 or 1. Analog read is going to read one of the analog pins. It will return a number between 0 and 1023. So I'm going to treat this analog read just like I would a digital read. I just get a different range of values out of it. I'm going to call a variable pot, and I'm going to save a 3 in it. Now what this is this is just a spot in memory. I call it pot. That's short for potentiometer. It's located in analog pin 3, and so I save the 3 in there, which means instead of having to type out analog read 3, I'm going to do analog read pot. It's going to read my potentiometer. My potentiometer is plugged into pin 3. It's going to take that reading. It's going to save it into a variable called val. And val is an int type. That means it saves whole numbers, and it can save relatively large numbers. It needs to be able to hold numbers between 0 and 1023, which an int can do. The other data types I've used so far are byte. Remember, the maximum for byte is 255, and so that wouldn't be large enough to be able to hold the large side of my potentiometer. Just to make sure everything's good, I'm going to start the simulation one more time. I haven't changed the LEDs since last time, so those should still be working. I am going to check my serial monitor. I'm just going to play around with this potentiometer for a second, and I'm just going to make sure that it seems to be working. So it does. So I have this all organized out. Now what I want to do is I'm actually going to make some space here. I could delete all these digital writes. I don't need them right now, but later I might, and I can just copy and paste those over. I can drag those where I need them. So I don't want to delete them. That's just going to save me time later if I just keep them at the bottom. But if I don't use them, I need to remember to delete those when I finish. So let's go over one more time and let's hit this example problem. We're going to use an analog read to find and store the value of the analog sensor. We've just done that. We're going to use this stored value. We're going to make an if statement. We're going to make an else if statement. And we're going to make an else statement. So let's go ahead and do that real quick. Anytime it tells me to make a bunch of statements, I can just go ahead and make those real quick. So I'm going to have an if statement. I'm going to have an else if statement. We do have videos on the if, the else if, and the else. I will be just mentioning briefly how they work as we go through this as well, though. All right, so if I do have a direct example like this, or a direct task where I say what type of statements to use, how many to use, I can go ahead and I can just fill those in right now, put them in their place so that they are there when I need them. So that is what the plan is for right now. I don't have anything specific in here. Use the stored values to use one if statement, at least one else if, at least one else statement to control the LEDs. It says to include comments. I haven't done that yet. I can go ahead and do that now, though. All right, so I have everything built so far. I have a nice structure built. Inside of these if statements, I can go ahead and start writing out what I want to have happen. I'm going to do it with pseudocode though. So in this first one, I could have something like turn on all the LEDs. In this second one, we can have turn off the LEDs, and I'll be a little bit more specific, turn off all the LEDs. And this else, we could do whatever we want. And I don't necessarily have to do this for the first one. I could say for this first one, turn on the first LED, for the second one, turn on the second one, for this third one, turn on the third one. I get to choose what I want to do, and we can use all the information we've done so far to pick what we want to do. For this else, I'm going to cycle. We've done a lot of cycling of LEDs. I'm going to blink all at the same time. All right, so I have this built in. I know what I want to do. Now I just have to figure out how to code it. The other thing we have to do is we have to figure out what we're going to put for these conditions. So previously, we've been dealing with buttons, and so I might write something like this. State is equal to 0. Else if state is equal to 1 or something like that. But what we have here is we have a range. If I wanted to, I could still do that. We don't have a state variable here, but I do have a val variable, and I can get a 0 if I turn this all the way down. But that's kind of boring because I want to be able to do stuff with the majority of what we can do. We have a large range here. I have 1,024 different values that I can get from my potentiometer. So it'd be nice to use some of those. What I'm going to do instead is I'm going to do if val is less than 400. I'm going to give it a range. The next thing I'm going to do is I'm going to give this one a range. I could say if val is less than 800. And then I have an else. Let's talk about what's happening here really quickly. If we're going to take this reading, and if whatever is saved in memory, val, if it is less than 400, then what's going to happen is we're going to jump into this if statement. We have the second one. We call it an if else, where we say if val is less than 800. Now, what's the difference then compared to having an if statement and then an else if statement after it? Why not just have two if statements? I'm going to quickly make a print, and I'm just going to print ABCD. And inside of my second if statement, I'm going to print 1, 2, 3, 4. This is just one way I do things. If I don't necessarily want to get the LEDs going yet, if I want to know specifically what's happening, I'm going to put a print somewhere, and I'm going to print something. Sometimes I just do some gibberish. Sometimes I'll print out entire sentences or specific words. Just to make it easy right now, I'm just going to do either letters or numbers. So let's go ahead and see what happens when we run this. Let's open the serial monitor. All right, it's moving really quick. I don't have any delays in here. We're printing when we get to line 19, the value of my potentiometer. That's why I'm getting this 0 in here, which is moving kind of quickly. But because 0 is less than 400, it's jumping into here and it's printing ABCD. The question might be, well, 0 is also less than 800, so why are we not printing a 1, 2, 3, 4? And that's the whole point of having an else if statement versus an if statement. Now, before we talk a little bit more about that, I just want to test this out. I'm going to turn this up a little bit. We see that we're getting different values. Now, I probably should put some delays in here so I can see what's happening a little bit closer. I'm going to go ahead and stop the simulation. I'm getting a 1, 2, 3, 4, and I'm also getting a 532. 532 is my potentiometer reading. It prints that number because on line 19, I tell it to print that. And it's printing the 1, 2, 3, 4 because we're getting into this else if statement. And this else if statement is printing 1, 2, 3, 4 because we are less than 800. All right, so let's make one quick change really quick. I'm going to change the code slightly. I'm going to change this else if to an if statement. So what happens if I just say, if we're less than 400, do this. If we're less than 800, do this. Let's see what happens just with that little change. All right, I'm actually going to go ahead and I'm going to put a slight delay in here because it is moving way too fast for us to really see what's happening. I'm going to do a half-second delay. All right, so it's moving slower now. It is reading 532. That's the potentiometer, which means it's reading, or it's getting into this if statement because we're less than 800. It's printing 1, 2, 3, 4. All right, if I move this down, we can see that the number's getting smaller, my potentiometer value is getting smaller. And when I get down to, I'm at 307, I'm going to stop the simulation real quick so we can take a look at these numbers. Potentiometer value is 307. 307 is less than 400, which means that it's going to print, it's going to get into this if statement, which means we print A, B, C, D. It's then going to check this second if statement. It is less than 800, right? Because 307 is less than 800, which means it's going to print 1, 2, 3, 4. And so what it does, it's getting into both of those if statements. And the way I have it written, these two if statements are independent. If I go ahead and I put the else in here, what it does is it treats these as connected. I have an original if statement that has some type of condition. I then have an else if statement, and the only time this else if statement runs is if the previous statements above it are false, the ones that it's connected to. So I have this if statement that says if val is less than 400. If that's true, then this else if and this else don't run because the first one was true. These words else make it so that only one of these connected scopes runs at a time. Now let's say that this first one is false. We get the number of 500 or something for val. If this is false, it's going to check the next one to see if it's true. Since 500 is less than 800, this second one would run, which then means that this last one wouldn't run because one of the previous statements above it was true. Now, if I have the number 1000 for val, this is false, which means we would then run the else statement. And so by putting the word else in here, what it does is it connects them all and then only allows one of them to run at a time. If I want them to all run independently of each other, I would use if statements. But if I want to connect these together so that only one runs, I use the word else. Now, if I want these connected, I can only have one if statement as my starting if statement. I can have as many else if statements as I want. I should have different ranges for them, of course. But I can have as many else ifs as I want. And what it does is it just checks which one's true. And if one's true, it ignores the rest. Now, if the first two are false, it's going to check the third one. And if it's true, then the rest get ignored. If this third one is false, it's going to check this fourth one. And if this fourth one is false, it's going to check this fifth one. Now, we don't have to do that. I for example 3 said that we're only having one if statement, one else if, and one else. All right, I'm going to go ahead and get rid of these serial prints. Those were just there to show us what's happening. I'm going to now go ahead and fill out this pseudocode. All right, so in this first one, I want to turn on all the LEDs. Luckily, I have some code in there to have that happen. So I'm just going to come up here and I'm going to print that in here or paste it in here. So if we get into this if statement, we do that if val is less than 400, then all 3 of these should turn on. Else if, let's turn them all off. That's going to be the exact same code, except for I have to change this word high to the word low. Now let's go ahead and try this out so far and see what happens. They are on. They should be on because my potentiometer is turned to 307. And if I turn it anywhere in this low range, those are going to stay on. If I get above 400, they turn off. And because I don't have anything in this else scope yet, it really doesn't matter what happens when I get all the way up to 1023. It would jump into this else statement, but I don't have anything there, so I shouldn't be seeing anything yet. Now, what happens if I pull this back down? They turn on. We do see maybe a slight delay, and the reason we see that delay is I put a delay in there. Let's go ahead and get rid of that. We shouldn't see as much of a delay. Any other delay that we see is strictly because we're using Tinkercad simulator, which sometimes delays a little bit. All right, you'll see how it takes a while sometimes for them to turn all the way off. That's okay, that's just a simulator. All right, stop the simulation. We're gonna go into here and we're gonna blink them all at the same time. We're going to turn them on. I'm going to delay for half a second. I'm going to turn them all off. We'll copy and paste this. And then I'm going to delay for half a second again. All right, they're off because we are in that middle scope, that else if. We're in our if, so they're on. And if I make it really large, get over 800, they should be blinking. I can just keep moving it around and it should keep jumping into the proper scope as I do that. Now, I didn't do a great job of putting comments in, but at the top of each if statement, we can see exactly what's happening. That's good. If you were to turn this in, I'd know exactly what's happening. If you were to share this with somebody else in class, they could read through this and they'd know what you would want to have happen in each if statement. I think that's the basics of it. Like I said, we'll talk more in class. If you have questions, let me know.